The Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRE, stands tall in the Indian industry with over 30,000 professionals and student members. Founded in 1981 and headquartered in Delhi, we operate from more than 50 chapters and sub-chapters spread all over India and members from across the world, expanding our horizon and bringing in our entire industry together. This vision has resulted in ISHRE growing internationally with the initial addition of 3 new overseas chapters at Bangladesh, UAE and Qatar. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRE disseminates knowledge through its technical committees, which consist of some of the best minds of our industry. It publishes technical books and a prestigious journal distributing a wealth of knowledge to all its members. Working with government departments, ISHRE helps formalize industry codes and standards. ISHRE promotes research by offering financial support to students members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRE Education Committee, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRE organizes exhibitions, conferences, panel discussions and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrix India, to showcase the cutting-edge technology, innovation and provide a platform for closer interaction amongst the decision makers in the industry. Our chapters organize several other popular national events like AcreConf in Delhi, AcreTech in Bangalore, Recon in Kolkata, Symposia in Mumbai, TechFest in Goa, Confluence in Ahmedabad, Asia Trends in Pune and many more. The chapters in India and overseas conduct theme-based national programs like Urjavaran, AcreServe, Pharma Connect and RefCon. Cold chain industry is developing at a faster pace in India. ISHRE promotes refrigeration and cold chain by organizing South Asia's largest exhibition, RefCold India, exclusively for this sector every year in Indian cities, and ensures a platform for global investment and community to connect with stakeholders. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests, and site visits. eQuest, a prestigious quiz competition organized by ISHRE to catalyze the transformation of the budding engineering professionals. ISHRE provides a platform to potential employers to provide career placement to student members by ensuring the industry provides job opportunities on our web portal, the first of its kind accessible to student members. A great opportunity for placements in the fast-growing HVACR industry with just a few clicks. Young minds are made aware of the need for saving energy, clean air and sustainability through interaction with industry. The K-12 initiative of ISHRE focuses attention of school students' development to inculcate a scientific fervor and help develop them into responsible citizens. ISHRE collaborates with various national and international societies and associations, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, energy efficiency and conservation. To enter and explore the universe of the Indian HVACR industry, log on to ishre.in that unfolds a panorama of information. Let us engineer a sustainable future together through ISHRE.
With the exponential growth in the Indian cold chain industry, it has been termed as a sunrise sector due to its immense potential and expected to grow to a staggering $36 million industry by 2027. Still, India faces an acute problem of appropriate refrigeration facilities, leading to 1.3 billion tons of food perishing in India. With a large spread of arable land, India is the world's largest producer of milk, fruits, vegetables, seafood and meat. Over 80% of the cold chain industry in India is unorganized and uses outdated and archaic technology, resulting in gross inefficiency and food loss. The cold chain industry is expected to grow at a CAGR of 14.3%. With the advent of food delivery, favorable government policies and innovative technology. With this market growth potential in perspective, we introduce South Asia's premier refrigeration and cold chain exhibition, RefCold India, which has a rich legacy of connecting experts and which enhances opportunities. After successful editions in Ahmedabad and Hyderabad, RefCold India is all set to catalyze the growth from the 12th to 14th of October 2023 at the Chennai Trade Center. With a coastline of almost 1100 kilometers, Tamil Nadu has been identified as a champion sector for boosting exports and helping the state realize its goal of becoming a $1 trillion economy by 2030. RefCold India is a state-of-the-art exhibition positioned at the very horizon of innovation. Key progressive innovations of the industry will be on display, with insights by the decision makers. With over 200 exhibitors, the exhibition would feature an innovation zone and a B2B networking area. RefCold India caters to industries such as fisheries, agriculture, horticulture, pharma, dairy, poultry, food preservation and reefer logistics. The RefCold India Awards Night will highlight and honor those at the forefront of this burgeoning industry. The Indian Society of Heating, Refrigerating and Air Conditioning Engineers is an organization dedicated to the advancement of the arts and sciences of the HVACR industry. Informa Markets in India is known for its expertise across the B2B exhibition sector and its ability to create innovative Indian Society of Heating, Refrigerating and Air Conditioning Engineers to present RefCold India 2023, South Asia's forefront exhibition for the refrigeration and cold chain industry. We invite you to join us in Chennai from the 12th to the 14th of October for RefCold India 2023, South Asia's premier refrigeration and cold chain exhibition.
The country is moving every year, and accordingly I think ACRE standard also has been going up every year. And no doubt that Mumbai has organized it very well, I met so many other leading consultants. I met my dealers partners. I met my old industry friends. And I'm pretty excited about it. And I want to compliment Acrex team.
It's been wonderful. I think the scale, the grandeur, the representation of the industry is, I think, really, really very good. And a platform like this, a show like this will definitely go a long way in educating people, in connecting the end users to the manufacturers, to the service providers. This is a great event, and I just hope that it gets bigger and better. I mean, it's already too good, to be honest. It's nicely organized.
My experience was really great because this year I have joined this exhibition in cooperation with our distributor and partner here in Indian market, Safe Refrigeration. So we have the possibility to get a deeper insight in Indian market. Acrex shape the industry in future in a way that the major OEMs, Indian OEMs are exhibiting here, and also the distributors. So of course it is a good occasion to meet the major player of the Indian market.
In my experience, this is exceptional. I feel so far this has been one of the best Acrexes that I've attended so far.
It is an ideal platform once a year, and I'm always excited about this event.
The experience in Acrex 2023 has been quite exciting, meeting with numerous customers and industry stakeholders alike. Really big ideas are here at Acrex. We'll certainly be back for the next year, looking forward to it in Delhi, 2024.
So, thank you and good evening, everybody, all the ISRE members and panelists present over here. As we know that today we are going to cover the workshop on disinfecting indoor air through UVGI, and this program is organized by Delhi Chapter of ISRE and supported by Alpha UV. We have our program chair, Mr. Waliullah Siddiqui. So I request Siddiqui sir to introduce the speaker for the day, Mr. Raghavan sir. Over to you, sir. Thank you.
Yeah, thank you, Mr. Tapas, for giving this opportunity to introduce Mr. Raghavan. This topic we are covering this last month also. We had a workshop on sliding indoor air through UVGI, and in that series this is the next one which we have planned. This is an online, so more and more members can join, and we have a lot of members which are joining in also. So thank you everybody, and I'd like to because Mr. Raghavan he doesn't need any introduction. He is very much known in the industry, but I would like to give a brief profile about him. He is a mechanical engineer with a specialization in air conditioning and refrigeration, and he has an experience of over 34 years in HVAC/R field. He has been working in application engineering, in sales, marketing, and key account management. He is passionate about energy conservation, indoor environmental quality, and sustainability solutions. He is the chair of ISRE Technical Group E111 on UVGI. So very learned person on disinfecting and sterilizing the air. And he is also member of the ISRE Technical Research Committee. He is the chair of ISRE Technical Group E111 on UVGI. And he's been in the technical committee in ISRE Technical Research Committee also. So he himself is the founder of Order Solutions, and this the company's consulting and manufacturing firm. So I would like to thank everybody who has joined in. I'd like to thank Team Alpha. I think Chandramani Jha is there. So I would like to thank them for sponsoring this. And this today's topic is more and more relevant because the for after the corona, we have so much focus is there on disinfecting the air and maintaining the indoor air quality, indoor environmental quality. So I hope this workshop enlightens everybody and we get the knowledge from Mr. Raghavan. So over to you, Mr. Raghavan, sir.
Thank you very much, Siddiqui sir. Am I audible?
Yes, sir.
Thank you very much for giving us this opportunity. I am sharing my screen to start the presentation. Is my screen visible?
Yes, sir. Perfectly fine.
Okay. So, as Siddiqui sir introduced me, I head the ISHRE E111 technical group. Many of you may be aware, ISHRE champions the cause of spreading, enhancing the knowledge across the HVAC fraternity by sharing whatever knowledge we have, ISHRE has gathered through different participant members for the further benefit of the HVAC industry. So one of the technical committees that ISHRE has formed during COVID time was E111 on UVGI. I am the chair. So I, from the technical committee, on behalf of technical committee, I thank Delhi ISHRE chapter for giving us this opportunity to share whatever we understand about UVGI application in HVAC with all of you. Our technical committee consists of experts from different walks of life. You can see we have about 6 voting members, people from consultancy background, contracting, end users, UVGI manufacturers, and we also have 13 more members. So it is good strength that we have people who contribute, who have applied UVGI themselves, who offer the technology and solutions to the market. So whatever we are going to present in today's event with all of you, this is a combined effort put in by all our members with the references to ISHRE position document, different ASHRE standards and handbooks, whatever we understand from our own experience and the practical knowledge of applying UVGI in the applications. So all that put together, we want to share whatever information we have with all of you. So over the next 70-75 minutes, we will be touching upon a lot of topics related to UVGI, understanding the basic principle, how does it disinfect, the lamp constructions. In HVAC, how do we apply, what and how it helps, benefits, IAQ enhancement, energy conservation, and how do we handle it safely, what maintenance care we have to take. Healthcare in itself requires and uses a lot of UVGI in a different application. So that we have put together as a separate topic for sharing with you. So we'll be talking about how UVGI used in healthcare. Whatever questions come to your mind, whatever inputs and suggestions you have on some of these points we are going to discuss, we request you to jot it down, maybe post it on the chat box. Once my presentation of about 70 minutes is over, maybe we will be able to have some question and answer session. Let me start with the history and basic information. Now, one disclaimer before we start. All of us are very familiar with UVGI application in the drinking water purifier that we use at home. UVGI is very much used in the drinking water purifiers, there is a difference between water UVGI and air UVGI. From the way they are constructed, the kind of energy they generate for disinfection, and the characteristics of UVGI absorption, that is called as attenuation. The attenuation rate is different in water and air. So our technical committee is focusing more on HVAC applications, particularly with respect to the surface disinfection in AHUs and related equipments, and the airstream disinfection. So whatever we are going to discuss, we should not be drawing a parallel or trying to further extrapolate it for water application. As of now, our technical committee is not looking into water application. Let me start with the UVGI history. Now, we will be quite surprised to know right from 1877 and 1900 onwards, this UVGI is known to the scientific fraternity. In 1903, Nobel Prize was given for using UVGI to treat certain illness at that time. The quartz lamp was developed in 1904, and as you could see on the screen, the water disinfection was demonstrated in 1906. And during the wartime, Second World War, TB was very much spreading in the US. So UVGI, particularly the upper zone irradiation units, they were used to disinfect public places, schools, colleges, to control the spread of TB among the public. Only in 2003, many US government agencies like EPA, FDA, they all recognized and appreciated the contribution from UVGI. And currently, UVGI, the upper zone irradiation unit, it is a regular feature in the USA healthcare facilities and documentations. And very recently in 2023, now ASHRAE has come out with a standard 241 on control of infectious aerosols. It is a good step forward because only in 2003, ASHRAE formed a technical committee on air and surface treatment. So there are two ASHRAE handbooks which talk about UVGI construction and UVGI application. From there onwards, it really started picking speed. Now, we all will be surprised if UVGI is known for more than 100 years. How come only during COVID time we all started talking about applying UVGI in HVAC? So the reason is what we understand through discussions in our technical committee, talking to experts. Whenever any pandemic starts, the vaccine has not been still discovered. Of course, UVGI is sought after, but usually after the vaccine is out, a recent example experience being the COVID times. Once the vaccine is out, immediately the interest in UVGI went away. So one thing that we need to keep in mind from the HVAC industry point of view is the primary reason for applying UVGI is definitely for disinfecting air, but it also contributes in enhancing the indoor air quality and also in further improvising the energy efficiency of HVAC system. So just because the pandemic is not there currently, the UVGI doesn't lose its relevance. So that is one reason we want to share how UVGI really can enhance the indoor air quality and improve the energy efficiency of HVAC systems. So the current presentation will be focusing more on those aspects as well. This is the new standard ASHRAE 241 that has been released, which talks of how to control infectious aerosols. What is aerosol and all we are going to discuss subsequently. So this particular standard prescribes the minimum requirements to reduce the risk of infection spreading in occupied zone through infectious aerosols. So it talks about mostly the air system design, installation, operation, maintenance, the CADR rate, etc. It's a good step forward. We are confident that it will further be detailing many more aspects with respect to UVGI and its role in controlling the disease-causing aerosols. With that brief background, let us move to how the UVGI actually works and how it disinfects different pathogens. We all know the light comes from the sun, and if you see on the left side top where my pointer is moving, we know the light spectrum has different colors. It comes at a different wavelengths, starting from gamma rays, X-rays, going up to the radio waves on the right side. It has a different wavelengths. That is how the visible light, of course, we are able to see. But beyond the visible light range, there are so many other rays that are coming from the sun, reaching Earth at a different wavelength. What is of interest to us is immediately to the left of the visible light range, this particular UV ray band, which spreads right from 100 nanometer wavelength to 400 nanometer wavelength. Now, we all know, being in HVAC industry, we have heard about ozone layer, alternate refrigerant scenario, etc. So if you look at the atmosphere surrounding Earth, this y-axis shows the height, altitude from Earth. So right from in the stratosphere, it consists a high concentration of ozone, whereas by the time we come near to the Earth's surface, the concentration level very much drops. So it is all concentrated in the stratosphere. So this ozone layer, if you further look on the right side, it also acts as a filtering element in filtering the UV rays. It doesn't filter the entire band. If you look at UVC, the UVC is spread from 200 to 280 nanometer. So the UVC is fully absorbed by the ozone layer. UVB rays, which spreads over 280 to 315 nanometer, 95% is absorbed, still 5% reaches here. If you look at UVA band, the UVA band 95% is absorbed. So, sorry, 5% is absorbed, 95% of UVA reaches the earth. So, this we may keep in mind, 95% of UVA and 5% of UVB reaches the earth, whereas UVC doesn't reach earth at all. When we come to the safety aspects of UV, we will be referring to these numbers to understand how to safely handle UV and what care we need to take. Now coming back and understanding what is this UVGI stands for, because we understand UV is ultraviolet. What is GI? So the GI refers to germicidal irradiation. So it is the inherent capability of UV rays, which has a potential to disinfect all the pathogens. If you look at this right side curve, this shows the wavelength on the x-axis and the germicidal efficiency, that is the ability to disinfect the pathogen. So if you see at around 265 nanometer, if you just see at where it is showing 100% efficiency level, 265 nanometer gives 100% efficiency in disinfecting the pathogens. But with the commercial lamps that are available, which are able to generate 95, which are able to convert 95% of their energy into UVC rays at 254 nanometer wavelength. So this is the best we are able to achieve. So 265 we are not able to produce commercially using a low pressure vapor lamp. Of course, continuous research is going on. How do we reach 280, 265 nanometer wavelength? So the 254 nanometer, which still gives 95% disinfection efficiency, this is called the germicidal irradiation wavelength. So it is exactly 253.7, but we round it off and normally we refer to 254 nanometer. So whenever we are talking about UVGI or UVC, it all refers to its capability to produce 254 nanometer wavelength. Now let us understand how does it disinfect a microbe. When this 254 nanometer wavelength, it is exposed, the airstream or a surface containing different pathogens, it could be a DNA or RNA structure, when they are exposed to 254 nanometer wavelength of UVC, what happens is generally the DNA structure is a twin helix molecular structure, as you can see here. It is sustained from the left side to right side with so many so the cell structure, you can see it is sustained from the left side to right side with a lot of proteins inside. So when this protein, they are exposed to the 254 nanometer wavelength UVGI, they are unable to sustain. So what happens is, instead of extending from left to right and supporting the twin helix structure of the molecule, they start fusing with each other and they break the structure. So when the structure is broken, they won't be able to sustain itself, because usually they replicate by feeding on the dirt and other contaminants on the surface. So they won't be able to reproduce further. So this is what we call as disinfection. Now, whenever we are in microbiological term, we are talking about disinfection. We do not say it is totally removed, because usually we talk in logarithmic scale, which we are going to subsequently discuss. So we call it a disinfection. So to a fairly decent level, we are able to make the DNA or RNA from its capability to reproduce. Now the question comes, which all pathogens will be able to disinfect? So whichever pathogens are known to science, it could be a bacteria, virus, fungi, algae, all kind of internal structure. So all that, whatever pathogens are known to science, we will be able to disinfect. Some of the popular pathogens which cause disease, which are known to us, which all of us will be able to recognize, like TB, SARS, influenza, adenovirus, aspergillus, measles, polio, penicillin, rabies virus. So all these we will be able to disinfect without any difficulty. Now, this is a chart from ASHRAE handbook. If you look at the susceptibility chart, susceptibility index, virus, bacteria, we will be able to disinfect with least amount of energy. We require more UV energy to disinfect and make these pathogens to retard. Like the bacterial spores and fungal spores, they require more energy to get disinfected. So these are called least susceptible. So we adopt different approach, which we will be talking about when we come to that topic. Now on the left hand side, there are examples given. What is vegetative bacteria, mycobacteria? One of the mycobacteria example is TB. So all these, they indicate a different kind of how dormant they could be. Some of the bacteria remain dormant at the right environment conditions. Again, they spring back to life and they start replicating. So all these pathogens with 254 nanometer UV rays, we will be able to disinfect. Now, talking about disinfection, before we go further, we need to understand what are some of the terminologies used. Now, the right side chart shows a curve, which actually depicts the rate at which the pathogen decay occurs. Decay means, it starts deteriorating or getting eliminated, disinfected, right? So this is not a linear relationship. Whatever energy, UV energy we supply, after a particular threshold value, which is called as the shoulder curve, once the threshold value is crossed, the decay goes exponentially. And the slope of this curve is defined by a term called the K factor. K factor is the deactivation rate constant of a given pathogen. This K constant is a very, very important term for all of us handling UVGI, selecting UVGI, applying UVGI to remember, because it varies from species. For different kind of bacteria, virus, fungi, spores, the K value changes. And establishing the K value in the laboratory is a complex process, because even during the COVID time, if you look at what is the energy, UVGI energy value required to disinfect the coronavirus, different papers, different manufacturers, suppliers, solution providers, they might have referred to different numbers. The reason why the numbers change mainly is because if they are referring to a different research paper, the K value for the same virus or bacteria could be different, because laboratory to laboratory, depending on from where the particular pathogen was sourced, how it was cultivated in the laboratory, right? Cultured to make it grow further, then they will be able to further analyze. So depending on the laboratory condition, the different kind of microbiological treatment it was subjected to, including from where it was sourced, and depending on what kind of experiment is being conducted in the laboratory. Depending on so many such variables, the K factor changes. So this is the reason we find different solution providers talking about different numbers. Now, the right approach could be, we usually refer to the values published by some recognized sources, maybe ISHRAE, ASHRAE, International UV Association. So like these organizations, papers or recommendations, if we follow, generally our design should be quite good to take care of the disinfection of pathogens. Now, the fluence or the UVGI energy that we generate in a HVAC application, it is given by this formula. What is energy? So it is usually given in terms of joules per square meter, or the energy generated is quite small. So it is also given in microjoules per square centimeter, either joules per square meter or microjoule per square centimeter. So the energy formula is, it is equal to the intensity, which is microwatt per square centimeter, multiplied by the exposure time. So this is something all of us need to remember, so that subsequent discussions will be easy for you to understand. The intensity generated or energy produced by the UV lamp multiplied by the times second exposure. So this is the energy that the UVGI system is generating. So please remember this. We will be talking about it subsequently. Now, coming back to our COVID time experience, many of you might have seen in the hand wash and a similar disinfectant, you might have seen 99.9% efficiency, etc. So now I want to explain what is this logarithmic scale of pathogen reduction. If you see this curve on the screen, the y-axis gives the percentage survival of any pathogen. The x-axis gives the UV energy, the dosage that we generate. That is the intensity multiplied by time seconds, right? Now, the y-axis, if you start from the top, 10% survival means 10% of the pathogen load remains and 90% is removed, eliminated. This is called as 1 log reduction. When we come to 1% survival, 99% it is disinfected, that is 2 log. So the 99.9 that we were referring to, that refers to 0.1% survival. So this refers to a 3 log reduction of the pathogen count. Many people who are in pharma business, they may understand, because there are certain tests conducted to look at what is the CFU value of pathogens in a particular environment. So here they may be able to appreciate this. Normally in HVAC design, if we do our design around 2 log or 3 log reduction, generally we should be well off. There is no need to go to 5 log or 6 log or 7 log reduction. which may be required in certain operation theaters or such similar healthcare application. Normal comfort HVAC, if we are around 2 log or 3 log, we should be generally good enough. So this particular line that you see, this is for the coronavirus, the COVID virus. Now, as I explained, different papers may give different numbers. The ASHRAE value for 2 log reduction, that is D99, that is how it is denoted. For CoV2 virus, that is 1500 microjoule per square centimeter. Now, you can see here for 1 log, this is another paper from Kowalski and Bianca. So if 1 log requires 1200 microjoule, by the time you come to 3 log reduction, it requires 3700 microjoule. So this is how exponentially we will be able to disinfect by giving more UVGA energy. Now the right side chart gives, this is a table from one of the handbooks. So here it describes different microbes. You can see all the names that are visible on the screen, the type, whether it is DNA, RNA, etc. What is the diameter? Generally, viruses are much smaller in size compared to bacteria. Spores are the biggest in diameter. Here you can see the K value, the K constant, which we talked about, which changes from research to research. Now, based on this K value, the D90, usually all the K values, all the handbooks, generally they give D90 value, 1 log reduction value. We need to look for a few more data to understand what is the 2 log or 3 log reduction value. Generally, the handbooks give 1 log D90 because the accuracy is more with D90 values. So this is how we look at the handbook for different microbe that we want to disinfect. For example, hepatitis C, if you see where my cursor is moving. So about 169 mean value, average value for 1 log reduction, joules per square meter will be required. So like this, we can easily refer the handbook and understand what is the UVGI energy that we need to give to reach a certain kind of disinfection. Now with that, let us move to the UV lamp construction. Some understanding of UV lamp construction will help us in being able to apply in the HVAC applications. Now, if you look at this picture, immediately we will be reminded of the fluorescent lamps, the tube lights we call them, which we are very familiar with, used in offices and residences mostly. It's very similar in construction. There are some differences which I will share. So this is made of a pure glass called as quartz glass or soft glass, because only they can transmit the 254 nanometer UVC wavelength outside the enclosure. The normal fluorescent lamps that we use at home, they won't be able to emit UVC wavelength because they are given a different coating inside the enclosure. That is how they don't emit UVC. So here it has these 2 electrodes, very similar construction. So the electrodes, they are coated with a special chemical so that the intensity of the electron excitement will be more. The amount of current that is flowing through the electrons will be more. This tube is filled with inert gas, very similar to fluorescent lamp. It also has an iota of mercury atom, less than 5 milligram, very small amount. The mercury atom is very much there. So what happens when we apply power, the electrodes get hot, they start, the whole inert gas, the electrons start getting excited. So with a particular ampere flowing through the electrode, the electrons excitement movement increases, and when they hit these mercury atoms, it vaporizes and start emitting the UV rays. So the selection of the lamp, the kind of pressure that is maintained inside, the kind of coating that is put on electrode, the kind of special coating given on the inner enclosure, all these put together ensure only 254 nanometer UVC rays are emitted, nothing else come out of this enclosure. Even ozone is never a concern with this kind of UV lamps, because as I explained, there is a special coating given on the enclosure from inside that will not allow ozone causing wavelength of UVC to come out. So only 254 nanometer wavelength comes out. So this is the working principle. Now you might have heard that the UV lamps have to be replaced after 9,000 hours, 12,000 hours, like that. So why that is required? Because the lamps may still be glowing, but the manufacturer guidelines is replaced. So why we have to do is, the special coating that is put on these electrodes, because they get vaporized over a period of time. Once they get consumed, the amperage that is flowing through the electrode, they lose in intensity, and they won't be able to excite the electrons inside with the same intensity, because of which the energy produced by the UV lamp, it keeps dropping over a period of time. So here, this is the reason we have to follow the manufacturer's guideline. After a particular run hours time, we have to replace, even though it is still glowing. Now let us talk about different material. Now both these material UV lamps are available in India market. Both can be used as long as they produce the energy that is required. There is no issues with either of them. Both are good to apply. So we should understand the characteristics of these lamps. Okay, that is why we are sharing this information. The quartz glass, they have the capability, depending on how they are manufactured, either to be used in HVAC application producing 254 nanometer for disinfection, or they can be used for different application for producing ozone. Because if you remember in the chart before, below 200 nanometer or around 180 nanometer, we start generating ozone. So if you change the coating inside the lamp, we can make the quartz lamp to generate ozone for different application, not for HVAC application. Okay, so that is one characteristic of quartz lamps. The second is the percentage derating at lower ambient will be very low. Means if you take 25 degrees centigrade ambient, after the AHU coil, the air temperature may be 13 degree. So naturally there is going to be a derating of energy of the UV lamp. So the percentage derating will be lower with the quartz glass. Now when we come to soft glass, with a soft glass, this cannot be used in any other application other than HVAC, because the characteristic of soft glass is such, it will generate only 254 nanometer wavelength for HVAC application. But compared to quartz glass, the percentage derating at lower ambient is high. Means you put after the coil, the derating will be higher. So what is done when these UV lamps are given? You might have seen in some of the applications, the UV lamp is inside a glass shield over it. Okay, there is one more circular tube within which the UV lamp is inserted and supplied. Why that is done is to minimize the cold air touching the tube and dropping its intensity. So the shield is provided to manage the derating. So this much we should understand why there is a tube over the UV lamp. Okay, hope this slide makes it a lot more easier for you to understand what you see in the field. So as long as the dosage to disinfect is delivered, both these glass UV lamps can be used. There is no issue. Now let us move further on the lamp types and terminologies. Now what we normally use in the industry today is low pressure lamps. The inert gas that is used inside, they are at a very low pressure. So they operate at around 33% output efficiency. So in this, there are three different types. Standard output lamp, where the ampere is around 425 milliampere. High output lamps. So mostly what is being offered in India, if you check with manufacturer, they all will be low pressure, high output lamps. They run slightly at a higher milliampere rating. So here the gas mixtures, pressures inside, some of the substances that are used inside chemicals, they are different from the standard output lamp. That is how for the same dimension, they are able to generate more energy. Amalgam lamps are used morely currently being used in some of the STP water treatment and all that. They run at very high current flow, and they generate much higher intensity, more than what we need for air conditioning application. Okay, so these are used in some of the STP treatment plant. We also have medium pressure lamps, though not very popularly used in HVAC application. Some of the current work is happening in the industry using LED. Now we know in the lighting industry now all the fluorescent lamps have been replaced with LED, right? LED has a lot of benefits. Similarly, work is happening, research is going on in coming out with LED UVC. As of now, their efficiency is quite low, roughly 1% compared to 33% of low pressure lamp. And the energy intensity they are able to generate, they are much, much lower than what we require in HVAC application. So currently these are being used in dental surgery application. They have not yet been applied in HVAC, but maybe at some point in the near future, we may be hearing a lot more about LED UVC lamp for HVAC also. But currently the market is mostly on low pressure, standard output and a high output lamps. Now, let us understand one more interesting characteristic. We were talking about the percentage derating, etc. So let us understand a little more on that. Now, if you look at this chart, we are going to discuss about the wind chill effect on the lamp. Now, if you see the x-axis, it shows the temperatures, and the y-axis shows the UV intensity output. So now you can understand the maximum efficiency, let us say, is at 45 degree for a given lamp. When this is the cold spot temperature, okay? This is the actual surface temperature on the lamp. So if the temperature keeps dropping to about 15 degree, which is generally the temperature we see after the coil in the AHU, the percentage output drops. The 100% may drop to somewhere around 50, 60, etc. So why this particular point is very important? What happens is, this is called the cold spot temperature of the UV lamp. Now we discussed the inert gas inside the low pressure lamp is filled with a certain pressure by the manufacturer. So if the temperature of the surface reduces, the pressure also will vary. If the pressure changes, the amount of energy emitted will change. Okay, that is how the UV output varies. So this is the reason, if you see the right side, if you take a standard output lamp, which is in dotted line, and the solid line, which is the high output lamp, this is the reason to compensate this percentage derating, to still make the UV lamp to disinfect efficiently. The UVGI manufacturers offer this option of high output lamp. Now you can see when the wind chill factor affects the performance. So you can see the caption. This is in a moving air stream of 21 degree with increasing velocities. We know there is a particular air design velocity inside the AHU, in supply air duct, etc. Wherever air is moving, it is moving at different velocities in air conditioning system. So both with the temperature and velocity, the percentage output of the UV energy will change. So this is the reason, compared to standard output lamp, the manufacturers recommend to go with high output lamp. But with either lamp, if the velocity increases, the energy intensity reduces. If the temperature drops, the energy intensity reduces. Okay, these two things we have to keep in mind. Now, one more point we want to bring to your notice is, whenever we are looking at any manufacturer's catalog, whenever you are looking at selection from the catalog for a particular energy output, you should always look at the rating conditions which are mentioned in the catalog, because some manufacturers, they might have captioned this is at a particular ambient temperature, or this is at still air application, etc. So from the design point of view, we need to check with the manufacturer. My application is going to be with a particular velocity, different temperature, not a still, not a 25-degree or 45-degree ambient. Okay, we need to explain all that, and then we need to apply the UVGI appropriately. This will help in getting the output exactly as per the design intent. Otherwise, we will have complaints subsequently that the UVGI didn't work as per the design intent. Now, before we move further and discuss about the actual application, let us understand which standards are applicable for UVC. Because we understood the UVC lamp construction is very similar to fluorescent lamp. They also use a ballast, okay, very similar to the fluorescent lamp. So as of now, the UV lamp standards are very similar. They all follow the fluorescent lamp standard with respect to abbreviation, like the sizing is T5, T6, etc., right? Which is similar to the normal lighting standard. The wattage, diameter, length, lamp shape, etc., etc. So very similar standard. This is how they are described. They follow similar standards. All the electrical components, they are all covered by these ANSI, NFPA, IESNA, and in India, they will have to follow India electricity rules also. Any safety classifications and certifications, they will have to comply with UL, ETL, CSA, etc., which are applicable for UV. Now, coming to the performance standard, is there a performance standard? So the UVC performance standards are covered by NEMA, ANSI, IESNA. So here what they do is, after 100 hours of running the lamp, powering them up, they take a photo sensor, UVC sensor, kept at 1 meter distance, 3.3 feet away from the lamp axis, at 25 degrees still air. This is what the standard describes. So this is how the UVC performance is declared. Okay, so this generally might have helped you to understand so far about number one, UVC 254 nanometer, they do disinfect any pathogen known to science, number one. Number two, the kind of lamp constructions that are available. This is mostly low pressure vapor lamps. Generally, high output lamps are used in India market. So this much we understood how they are rated, what is the cold spot, what is the effect the moving airstream high velocity has on the UV output. Now let us move to understand how it is actually applied and what could be a better way to apply it in HVAC application. Now, when we come to UVGI application in HVAC, there are two types of disinfection possibilities we are discussing. One is surface disinfection. Where all surface disinfection could occur? You might have seen a lot of fungal formation, even in inside office or in hotels where the FCU grills are fixed, or even in offices where the supplier grills are there. After few months of operation, you see a lot of black color formation around the grills, inside the AHUs. When you try to access the AHU for maintenance, you walk in, you could see some fungal formation. So usually wherever it is wet, dark, with the possibility of presence of dust or dirt, because the pathogens feed on dirt. Okay, that is how they replicate, by taking that as a nutrient. So wherever this source is available, whichever is a dark place, wet place, naturally fungal formation occurs. So in air handling unit, which are they, or in HVAC, which are they? Generally the AHU coil, because it is continuously sweating, and also could be having some dust and dirt. Even though the filter might have cleaned, it is not 100% efficient, right? Depending on the MERU rating of the filter. Drain pan, because some water particle may still be sticking around, might not have drained. AHU plenum, because it is wet. Supply air duct could be some, still it is moist and wet. That is the reason. So all these are potential regions which will require surface disinfection. So Compared to air disinfection, surface disinfection is quite relatively easy because taking a coil or a drain pan, they are not moving, they are static. So we can put a UVGI lamp focusing on that surface with a reflector, etc., enhancing the intensity, and we will be able to very successfully disinfect them. So this is on the surface disinfection. Now let us talk about air disinfection to understand what it is. So air disinfection means we are talking about moving air stream with less than a second exposure. Why we call it less than a second? You take a air handling unit. Normally we design air handling unit at for 500 fpm velocity, phase velocity, right? So 500 fpm you convert, divide by 60 in 1 second, what distance it will travel. So 500 divided by 60, about 8.3 feet it travels air at that speed in 1 second. Now, so in 1 second, it travels 8.3 feet. Not all the AHUs are having a length from inlet to outlet 8.3 feet. Maybe some, maybe many are not. So this is why we say we get less than a second, millisecond exposure. Within that time, we will have to disinfect the airstream. Okay. So this is a little more complex compared to surface disinfection. This will require more energy, which we understand. And from where the source is coming, meaning from where the infection creating particles are coming, mainly this comes from fresh air, because in all HVAC system we take fresh air. It could be coming from outside. It could be coming from the recirculated air, from people, contaminated surfaces on its path, return air stream, etc. So like this, these could be the sources. So with this basic definition, let us now start discussing about how do we disinfect, how do we provide solution for surface disinfection in HVAC. We will start with AHU. Now, many of you may be able to recognize this is a cooling coil on the air handling unit. This we call, whatever you see, that white color sticky thing on the fin surface, this we call as a biofilm. Biofilm is a mass of mold and bacteria which is forming by sticking to the finned surface. They feed on the dirt, and usually what happens, once they start growing, they excrete a slimy substance, stick to the surface, and they grow, replicate more. Depending on what pathogen we are talking about, the replication time varies. Could be few seconds to few minutes, something like that, but they replicate. And usually in AHU design, we HVAC guys are familiar. It could be having a 6-row coil, 8-row coil, etc. Though we may clean the front face surface with a brush or with gently flowing water stream, etc., etc., we can't be sure what is the status condition of the finned surface. Is it clean or still having this biofilm inside the depth of the coil? Like for example, 4th row, 5th row, 6th row, is it clean or not? There is no way to know. And usually these kind of biofilms, even if we scrub them with a soft brush and remove, they come back. Because if it is only dust, it should not be growing on its own. Because it is biofilm, it starts forming again. And the coil drain trace, wherever water stagnates, there the microbes start breeding. The AHU plenum and supply air also have a lot of fungi growth. Now, how do we know this is only biofilm, meaning pathogen mass? It is not dirt. This you can check with a simple Petri dish. This is also referred as a Sabdex plate. Sabdex is an abbreviation of a of the chemical that is used inside. You can simply take it as a pathogen food. Okay, it's hardly our palm size. So this comes sealed in a visible enclosure. This is how it looks when it is fresh new. So when we want to evaluate, is this a biofilm or dirt, what we do, we go close to the coil, quickly remove the cap, touch the surface on the coil, and again put it back very fast, and seal it with a cello tape or a very nice sealant so that air cannot enter. After 48 hours to 72 hours, you will see all this kind of growth happening, okay, on the subduct plate material. So each and every color that you see here, it indicates a different kind of pathogen. What normally we see in HVAC, because as I said, there are many manufacturers offering this kind of solutions for a long time now, though we are not regularly applying it in our HVAC design. From their experience of sending it to laboratory, doing a culture test and all, they have established most of the HVAC applications will have this kind of gram negative and gram positive bacteria. The gram negative and positive indicates the cell structure. Are they resistant to antibiotics or not? Okay, this is a microbiological term. So usually these kind of bacteria and these kind of fungi will be mostly present. You do any kind of HVAC subduct test, send it to laboratory, you will see mostly it is coming out as Aspergillus niger or any of these things. Okay, so this is how we establish and we can confidently say it is a biofilm and not a duct. So another question may come in our mind, okay, if it is a surface, coil, etc., we can touch. What about airstream? How do we know? How do we test? Very similar. Maybe expose this subduct plate following a right way of collecting the sample by exposing the subduct plate in the outlet air plenum of AHU or in the occupied space from where the supply grill is throwing air, and then we seal it, send it to the laboratory, and then they have their own procedure to follow, incubation for certain time, etc., etc. And then they will give us the report. So many CFUs, colony forming units. Okay, that is the term used, and they will give the numbers. So generally, whenever we send it, it could be in thousands or many hundreds generally. And usually after applying UVGI, it will be very close to 0 or in single digit, 7, 8, 4, something like that. That shows the effectiveness of UVGI in HVAC application. That gives us the confidence. Yes, applying UVGI has really brought the pathogen load down. Now, the impact of biofilm is also the heat transfer, the airflow resistance to airflow, and also IAQ. This we are going to discuss subsequently in few minutes time. Coming back to surface disinfection. Now we understood what is surface disinfection. So now what do we do? How it is attended to in the site? So the manufacturers, they offer, because this is a surface disinfection, we want to focus more energy on a static surface. For example, a coil or a drain pan, etc. So they offer with a reflector enclosure at the back at a certain angle, and this is a polished aluminum with a little more coating, etc., so that it will enhance the UVGI intensity. Whatever the lamp is generating, it will reflect. Maybe 25, 35, 45% more UVGI energy will be focused on a particular spot. Okay, this is how the surface disinfection lamps so far were being offered. ASHRAE recommends 100 microwatt intensity. That is what the handbook says. But while taking this number, we have to understand this is for 24/365 non-stop application. So one of our practical experiences in many IT companies or commercial applications, many people have applied it in air handling units. So they operate it for 8 or 10 hours. In the evening, 6 o'clock or so, when they go home, they switch off entire power supply. They don't want to energize anything, right? So if they are going to switch off and energize for 8 hours or 10 hours during day, keep it off for the balance 14 hours, 12 hours, like that. We discussed that every few seconds or minutes it replicates whatever is left off, right? So it will come back again. So this is one of the reasons wherever we have gone strictly with 100 microwatt intensity for selecting the lamp, we don't see the result. Why we don't see the result is we have not followed this 24/365 guideline. Okay, it is not explicitly mentioned, so we have not understood that. So if at all we are going to apply only for a 8-hour application, HVAC application, it goes without saying the intensity has to be high. Now, how much high, how to check the effectiveness, we are going to discuss. One more thing we have to understand while applying UVGI for surface disinfection is the UVGI intensity that it generates, the intensity is inversely proportional to the square of distance. Okay, means it is not a linear relationship. What do we mean by that? Let us take this blue color circle you see is the lamp. So at the lamp, near the lamp, we are measuring, let us say a unit of 100, whatever it is, 100 unit. When you move 150 mm, okay, 6-inch from the lamp, the 100 intensity becomes 13. When you go to 1 foot, 300 mm, it becomes 7. This is what is meant by inversely proportional to the square of distance. The more the distance, the intensity drops, not linearly, but as square of distance. So when you go to 1 meter, 3.3 feet, as per the rating standard, you may remember, one of the earlier slide we spoke about, the standard says, measure the intensity at 1 meter from the lamp, right? So the 100 becomes almost 1. Okay. So this is not a hard and fast rule. Manufacturer to manufacturer, instead of 1, this could be 2, 3, 4, whatever. This is an indicative information for all of us to understand what is this concept of UVGA intensity varying inversely to the square of distance. Okay, this is just to explain that point. What this means is, if you are applying UVGA to disinfect coil, the closer you come to the coil, the higher the intensity. Okay, that is how we interpret. But there are few more application guidelines which we will talk about. One more question we always discuss, debate while talking about surface disinfection is, should it be installed upstream or downstream? Now, ASHRAE recommends install it downstream. Downstream is after the coil, meaning with respect to the airflow, it flows through the lower mixing chamber, etc., filter, coil. Then between the coil and the blower, in this plenum, we keep the UV lamp. So this is downstream with respect to the coil location. ASHRAE recommends locate it here. What is the advantage of locating here compared to upstream? Upstream means near the filter, between filter and coil. Okay. When we cannot access the drain pan from near the filter side, from the face of the coil, if you open the filter, you cannot see the drain pan. So putting upstream, you cannot get access to the drain pan, you cannot get access to the plenum. So by putting downstream, you get access to the coil, to the drain pan, to the entire plenum. So the entire plenum and all these surfaces could be totally disinfected, number one. Interlocking becomes a little more easy, because if at all for maintenance purpose you want to walk in, you don't want the UVGI to be on when you enter. So interlocking becomes easy. The leakage irradiation, which we will talk about during the safety discussions, if it is inside a sheet metal, we discuss UVGI cannot pass through other than quartz or other than soft glass. So through the AHU metal body, it cannot escape. So it is very safe to mount it downstream. The one advantage of putting it upstream, you may remember, if the air temperature is higher, the intensity is more. So compared to downstream, where the air temperature could be 12, 13, 14, the upstream will be the return air temperature, 24, 23, 25, like that. So compared to 13, the 24 or 25 return air will give higher intensity. But only thing is, beyond coil, we won't be able to disinfect anything else. We have to think of some good way of interlocking this, so that whenever people walk into the AHU room, they are not exposed to any leakage irradiation. So we have to take care of this safety precaution. Now, let us look at some of the pictorial illustration and actual site photographs to understand surface disinfection better. So this is a moving airstream, the left side picture, if you see, coil, it is mounted downstream. You can see the reflector at the back. So it is focused all its UV energy on the coil. So the photograph on the right gives you a better idea how this is done. you can see from left to right, top to bottom, the entire coil is bathed in UVGI energy, right? UVGI, the way it works is, it is a line of sight device. What is line of sight? Wherever the UVGI is impinging directly, it will disinfect. Now, if you see this dark shaded place behind in the AHU, right, where my cursor is moving, UVGI energy is not falling on these dark shaded places. Whatever is forming here, any mold or algae, it won't be able to disinfect. Okay. So it is a line of sight device. Whatever is in its line of sight, it will disinfect. You can see even the drain pan, it is fully baked. So we can be sure that it all will be disinfected. Now, how do we select the UVGI for coil? So what we try to do is, the entire surface of the coil we want to focus with UVGI energy, left to right and top to bottom. Usually we give about 12-inch gap, 1 foot gap from the coil to the UVGI fixture. Now, to increase the energy, people may reduce the gap, bring it to only 6-inch or 8-inch from the coil. But what happens is, with the reflector at the back, we won't be able to totally bathe the whole coil surface with UVGI energy. You go very close, because of the curvature of the reflector, there will be shades formed on the coil also. Okay, so we won't be able to give a very effective disinfection for the coil. So how the number of lamps are selected? We check with the manufacturer. These lamps are available right from 1 foot to 5 feet. Maybe manufacturers may offer different length also. Depending on the coil length, we go for similar matching length, so that left to right we are able to cover. Number of lamps will be selected depending on the coil height. So many manufacturers, they have either selection software or Excel calculation guide, etc. If we give the coil size accordingly, the number of lamps will have to be selected. Not necessarily we have to mount only one lamp across the length. We can put two in 2 rows also, depending on the coil configuration. Wherever there is a gap on the left side or right side of the coil, we are also permitted to mount the UV lamps vertically to cover any uncovered portion of the coil. With that, let us move to airstream disinfection. In airstream disinfection, what we do is, as we discussed, we have to disinfect in less than a second. We took AHU example. 8.3 feet per second is the air speed. So if we are going to mount the UVGI downstream of the coil, okay, between coil and blower inlet, we require minimum 3 feet. Why we require minimum 3 feet? The reason is, ASHRAE recommends we have to disinfect the airstream within 0.4 seconds. That gives the effectiveness. So taking this 8.3 feet per second, if you want 0.4 second exposure, if you multiply that 8.3 feet travel distance in a second multiplied by 0.4, roughly 3.3 feet we will be getting. So if we have a gap of about 3 feet between coil and blower inlet, generally we should be able to do airstream disinfection also with 0.4 second exposure time, if we are able to generate enough UVGI intensity, okay, with the right number of lamps generating that energy. If you have 3 feet distance between coil and blower, that gives 0.4 second exposure, we should be able to disinfect the airstream. If this is not possible, then we will have to do the airstream disinfection in the supply air plenum in the AHU, or in the main duct somewhere just outside the AHU room. Now, for selecting the required lamps, what we do is, we need to know which microbe we want to disinfect. What is the degree of reduction, 1 log, 2 log, 3 log, because they require different kind of UV energy, and where we want to do it. Is it AHU or duct? AHU, the velocity is 500. After, of course, after the fan, it goes up. And if it is supply air duct, It is normally in India, we design anywhere from 1200 to 1500. So we need to check the design duct velocity and suitably calculate 0.4 second exposure time. So the distance varies between AHU airstream length and duct airstream length. Again, this slide gives a pictorial view and a photograph to make all of us understand how the airstream infection is done. Now, there is a difference between the surface disinfection photograph and this photograph. In surface disinfection, you might have seen a reflector at the back of the lamp. So the UVGI rays were focused only on the coil under the drain pan. Here, the reflector is not there. It is a 360-degree irradiation. So you can see the lamp. It gives 360-degree irradiation on all the sides. And this is how practically it is mounted on the mounting frame. You can see in some places it is overlapping the UV lamp because we need to generate so much energy. So once we calculate how much energy we need to generate within AHU for airstream disinfection, then we can suitably select the length of the lamp, number of lamps required from manufacturer's guidance or selection booklet or software. Okay. Now, when we talk about airstream disinfection, automatically it also provides surface disinfection. So the current trend is because this kind of a 360-degree lamp provides airstream and surface disinfection. Normally, the current trend in India market is previously, if it is a 10-year, 6-year-old installation, like some of the airports, metro stations, you will see lamps with the reflector. The current trend is to go with 360-degree lamp because it provides both surface and airstream disinfection. So this is what this slide explains. Now, if it is only surface disinfection, only low intensity lamps should be good enough. But if you want air disinfection, we need high intensity. One more design aspect is we want to do it in single pass air disinfection. Why single pass? Because from the air handling unit, we have a very wide duct network running inside occupied space. There could be so many cabins, conference halls, very large workstation, etc., etc. So from the supply air path, the air has to go mix well in the occupied zone, etc. Rise in temperature, maybe because of the, if you do CFD analysis, we know exactly in which way the airstream is moving, whether it is able to bring back all the air pollutants from the occupied zone or not. A CFD analysis will help us. So it brings back everything into the return air grill and through that to the plenum and the return air duct. Now, if we are talking about aerosol, we can't be sure if the aerosol will come back again and again because aerosol by definition, these are all small water droplets, right? While talking, coughing, sneezing, we emit. So not necessarily they will travel with the airstream and positively come back to the AHU. We do not know when it will reach the AHU. We don't want to take chance because we are talking about airstream disinfection, providing a very safe occupied air conditions, right? So we want to design airstream disinfection with just one pass intensity. So we don't want to take a chance. So unlike some of the hospital indoor unit circulation, in hospitals, there are certain units which are made just with a filter UV lamp and a blower, which keep on circulating in a ICU ward, etc., etc. There may be because it is a isolated room, small size, and the CADR may be more, we can be sure, we can consider more number of passes. But if it is a comfort HVAC application, large office, then we have to design it for single pass disinfection. Then we can be very sure it is a safe design. Now talking about duct, if we don't have enough space in the AHU, we have to do it only in the supply air duct. as we discussed, the wear velocity is 3 times the AHU. So you require a disinfected length of more than 9 or 10 feet. Okay. Because if you take 1500 FPM velocity in a duct, you calculate 0.4 second exposure time for the airstream, you will need at least 9 or 10 feet. So you will require that much more high intensity to be generated to disinfect the pathogen. Another way is, if possible, you have enough space, we may very well diverge the supply air duct, make the supply air duct size bigger, drop the velocity, disinfect, and again you can converge the duct size if possible. If it is retrofit application, enough space may not be available. So please think of all these aspects before you go for duct stream air disinfection. And while going for duct stream air disinfection, the way we mount the UVGI, for example, one way is mount it in a cross flow fashion, meaning you remove the duct insulation, drill holes, depending on number of lamps you want to insert in either 1 row or 2 row or 3 row as per your design. So that after the life, it becomes a little easy for you, for the maintenance team, to remove the lamp and replace the lamp. If we totally cover them inside the duct, embed them inside the duct, then for replacement, we need to stop the AHU, take a shutdown. Only during weekend, you can remove the entire duct section. You will have to replace and put it back. It is quite a job. And normally, maintenance team may tend to ignore replacing the lamp. And second thing is, whenever we are drilling the hole to insert the lamp, because this is supply air duct coming at high velocity, if the lamp length is more, you have to support it. Otherwise, because of the cantilever action and the high velocity air pushing it, the lamp may break. So, and the leakage radiation, we have to take care. No leakage irradiation should come to the occupied space. So these are some of the practical aspects we need to consider while going for duct stream air disinfection. Okay, this is just a pictorial representation. With this, let me jump quickly to IAQ and energy, then safety and maintenance, then we can have some question and answers. I will wrap up in another 10-15 minutes, my portion. So talking about the indoor air quality enhancement using UVGI. UVGI plays a very important role. This particular picture is from 2019 HVAC application handbook of ASHRAE. Generally in healthcare application, many of us may be familiar. In pharma application, we go for, in certain rooms, 12 air change per hour, etc. ICUs, operation theaters, etc. Patient rooms, right? So some of the healthcare guidebooks like Australian standard, few other standards, they say if we are able to build in the occupied zone a UV energy zone using upper zone irradiation units, and we are able to bring in supply air through this plenum in the room, pass it through the UVGI irradiated zone, maybe the number of air changes themselves could be reduced, because the UVGI provides all the disinfection that we require. Because the number of air change, why we go for 12 or any X number? Because it dilutes the contaminants inside, right? All the disease causing pathogen. That is the reason why we go for particular air change per hour. So UVGI is a very good solution in optimizing, in enhancing the indoor air quality. Okay, so this is what we want to look at in the current scenario. Though the pandemic has gone, the pandemic also has brought this question into many end users' mind. How safe is my workplace? So like how few years ago, LEED rating or green building rating was a catchword, and many people wanted to make their workplace a lot more greener, environmentally sustainable and all that. After the pandemic, one thing which every employer wants to ensure is all their employees coming to their workplace, they all are working in a very safe environment. So the wellness certification is one more interesting thing which is catching up. So many officers are going for wellness certification as well. This totally depends on the air distribution design. How do we take care that the disease causing aerosols are well controlled using suitable filtration and UVGI application. Now let us come to what is this aerosol. This is from the ASHRAE position document, this particular blue color illustration. Depending on the diameter of the aerosol is, you can say, the sort of water-laden pathogens, right, which comes out while we are breathing. If we are ill, then when we talk, sneeze, cough, we emit a lot of this infection causing droplet nuclei. Depending on the diameter, it takes its own time to settle down. Bigger diameter particle settles down very fast in few seconds. Very small diameter particle like the COVID particle and all, they will be airborne before they settle down. Okay. So this is how, if the air distribution design is good, then we should be able to get these aerosols back into the AHU. And if we design UVGI systems for only one pass disinfection energy rating, then we can be sure we will be able to take care of this disease causing aerosol spreading from one cabin, one conference hall, from workstation across the entire floor plate of the office. We will be able to protect against this. Usually while talking about aerosol control, diluting the pathogen count in occupied space, etc., there are different design concepts, including controlling at source, bringing in more fresh air, increasing the number of air change, also adopting the technologies. So during the pandemic time, we have done a lot of exercise. Will bringing in 100% fresh air, could that be a solution? It is not, because if you bring in 100% fresh air, meaning convert a existing AHU room, instead of taking return air, it will bring 100% fresh air, condition and supply. We require a higher chiller plant, because during monsoon the load goes up, chilled water delta T increases across the coil. It's not a very practical solution. Second thought many clients had, and which we discussed in our technical committee, is shall we put HIPAA? Because generally we are very familiar with HIPAA in healthcare application, pharma application. Shall we go for HIPAA 13, 14 and all those ratings? What happens is, normally we are talking about retrofitting existing AHU, right, in comfort application. So fitting HIPAA will require increasing the AHU length, because HIPAA requires a certain maintenance care, access from the front, back, etc. To follow the standards. So at least by 1 meter or 1.5 meter, we have to increase the length of the AHU to accommodate a HIPAA. So this is also not practical. So the right way to do is, if we can go with a MERV 13 filter, because this is what ISHRAE position document and ASHRAE position document recommended during the pandemic. Putting a MERV 13 filter along with UVGI, this is a very effective solution. Now, like how ASHRAE comes out with MERV ratings for the particulate count, and how do we check the efficiency of the filter, etc. We have this international UV association called IUVA. To make it a little simple for the users and design consultants, contractors to understand this UVGI concept, they came out with a URV rating, like how MERV rating is there. With similar URV rating, they came out with. This is called UVGI rating value scale. Okay. Here what they did, they went with a particular UV dosage, energy value. For example, if your UV system, number of lamps you selected inside a AHU or inside a duct, let us say it gives 1000 microjoule energy, that is equal to 11 URV. So this shaded portion, 10 URV to 15 URV, this is the range which will be very useful to HVAC application, right? There is a very equivalent MERV rating also they have shown side by side. If we can generate this much energy, for example, 2000 microjoule is equivalent to URV 13. So if we can generate URV13 kind of UVGI energy, they have tested with different virus and bacteria, adenovirus, influenza, TB. So this is the kind of disinfection rate it will give. MRSA is one of the virus which resist antibiotics. Okay. So with these 4 different pathogen IUVA has tested, this is the recommendation they give. So if you go with a URV13, 2000 microjoule energy, TB will be disinfected 100%. Now this 100%, as we discussed, this could be 99.4 log, 5 log something. Okay, this is all rounded. Otherwise, the table becomes very cumbersome for us to read. So 100 is a indicative number. We will be able to significantly reduce. Okay, so take it that way. So looking at this table and clubbing with Meru 13 rating, if we can design a system, then the output, what we are able to achieve, is quite significant. So there is one more test done, taking 52 different microbes, different microbes. That is what is mentioned here as a test array, right? From so 52 microbes were taken. What was done was no Meru 14, no UVGI. So the pathogen count is very high, 100. We applied Meru 14 filter, okay, Meru 14. With Meru 14, whatever the shaded portion you see, only these pathogens, different pathogens that we took. So significantly, we were able to reduce the pathogen load. The gray shaded area, this much we were able to reduce by putting a Meru 14. So you see the peak of certain pathogens. Majority of the pathogen, it was as good as disinfected. Then after Meru 14, URV 14, that is 2000 microjoule energy was applied. With that, what happened? The gray shade also was gone. This hatched portion also is gone. Only these inside gray peaks remained. Means only some of the microbe had about 30%, 20%, 10%, they still survived. Whereas majority of the pathogens, we were able to disinfect to a significant level. So if we can design HVAC systems with a suitable MERV filter rating and a UVGI, the pathogen load we will be able to significantly reduce. So this will help us to future-proof our HVAC system designs for all our workplaces, residences, any application that comes to your mind, public places like airport, malls, etc., metros. So this is another pictorial representation. So if you take a Meru 13 filter, take 85% efficiency, consider a pathogen load of 1 million, 10 lakh particles. So you pass it through Meru 13 with 85% efficiency, 10 lakh becomes 1.5 lakh. Then apply URV 13, 1500 microjoule at 3 log reduction. So what you get, pathogen load. Okay, this is not particle count. Okay, please don't get confused with dust level count and pathogen count. Here we are talking about pathogen count because dust level is taken care by Meru 13. For comfort application, that's more than enough. So the pathogen count we are able to significantly reduce. If you see, it is 99.999, about 5 log reduction. We don't need 5 log. So URV 13 could be reduced to URV 11 or 12. So UVGI energy could be reduced, or instead of Meru 13, a Meru 12 filter also should be good enough if the design approach is on the pathogen count. Okay. If you need Meru 13 only for the PM count, so please stick to Meru 13, then you may optimize the URV energy. So this is one approach which could be adopted in our day-to-day life while applying UVGI in HVAC application. So after this indoor air quality enhancement, let us talk about the energy efficiency improvement. How UVGI will improve energy efficiency, which energy efficiency it will improve. Okay, let us understand that. Now looking at these two pictures, it is obvious if the fin surface heat exchanger can be like this, devoid of any micro biofilm, then what happens is, number one, the thermal heat transfer goes up. chilled water delta T improves. The restriction to airflow, friction that is offered to airflow, this will significantly reduce if the fin surface is clean. Okay, so the fan energy can be reduced. So there are some ASHRAE reports. In the next slide, we will see what is the finding of these ASHRAE reports. At least 10 to 20% of overall HVAC system energy we will be able to improve. Now, these are the three ASHRAE research reports that are available by applying UVGI and studying the effect on the AHU coils. You will see all the reports showed significant reduction in air side pressure drop. So AHU fan power can be saved, and 15% increase in air side heat transfer. Here another report said they could increase delta T of 0.6 degrees centigrade. So these numbers are available. So for our own site, assuming we are looking at a retrofit, what we can do is we can assess our own site where we are present, evaluate quickly, is our AHU having a EC fan or VFD driven? Is it locked, or can we make it automatic? Naturally, a constant flow AHU fan is not going to give any energy saving, right? Similarly, is the secondary pump having VFD, etc., etc. We can evaluate, assess for our own workplace, and then we can come out with a good representative number which we will be able to achieve. Generally, in India, from our experience in airports, metros, different office applications, at least 8 to 10% overall energy saving have been achieved by reducing the AHU fan energy and improving the heat transfer across AHU coils. And naturally, it will have energy saving from the chiller and pump as well. There are many case studies available on International UV Association website. Of course, different UV manufacturers also have their own case studies to share with you. Now let us move to safety and maintenance before we take few questions, if there are any. Talking about safety, different associations like CDC, NIOSH, they have conducted a lot of experiments. They have come out with the threshold limit value or recommended exposure level value, REL or TLV it is called. So ASHRAE handbook very nicely tabulates. Generally, we go with a 8-hour exposure, meaning up to this exposure, this kind of irradiance leakage, it won't cause, meaning this is permissible. Okay, that is the caption. This is permissible. Beyond this, it is not permissible. So normally taking an office, if we are able to keep the leakage irradiation within 0.2 microwatt intensity when measured with a UV sensor, that should be good enough. Okay. Now, what will happen and what will be affected by exposure to UV? Two things. Number one, we have to protect our eye because exposure to UV may lead to this photokeratitis or a conjunctivitis. Simply put, in easily understandable language, it will result in red eye, okay, eye infection. Now, it may not really damage the eye unless the exposure time is very high or the energy intensity produced by the lamp is very high. It doesn't matter whether you are looking at the lamp or not. If you are close to the lamp and UV energy is falling on your eye, because we understood it is a direct line of sight instrument, right? If UV energy is falling on your eye, even though you are not looking at it, it will still create a red eye. So we have to be cautious. We have to protect our eye maybe with a normal goggle. Unless it is a quartz glass, UV cannot penetrate. So whatever specs we are wearing, that also is good enough to protect against UV. We have to cover our body fully. The forearms with a full sleeve shirt, fingers and palm with a gloves, etc. Face maybe with a mask, right? Ear, cheeks, everything we have to cover. Hair. If we are covered head to toe, even with a normal clothing, generally UV won't penetrate and there will be no kind of issues. Assuming the skin is exposed, what happens? It leads to a reddening of skin, very similar to the sunburn we have. So that is what happens. Though it doesn't cause any skin cancer and all, because the intensities are much lower. Now, some of the measurements that we do at site, you can see before we walk into the AHU room, we see is there any leakage irradiation through the coil, through the filter into the AHU room. Generally, we find it is all zero. We check on all the sides of the AHU. Then we walk inside, then we measure on the coil what is the intensity. So you will see the susceptible portion of the coil are always the corners 1, 3, 4, and 6. So those are the areas where you will see the intensity values are less. At the center of the coil, the intensity is always high. So with a measurement, we understand what is the intensity we are having. Wherever we want to increase the intensity, we can always add a lamp. Even vertical lamps at both corners are allowed to increase the intensity. If at all we have a concern that we don't want any glass pieces breaking and falling within the AHU, within the duct, the UV lamps are also available with a special sleeve, so that even if it breaks, nothing will fall. It all will be contained within the FEP sleeve. The sleeve material also is selected in such a way it will allow 254 nanometer UVC to come out. But in normal comfort application, we don't recommend, because unnecessarily it increases the cost. And whoever goes for maintenance inside the AHU, generally these are all trained people. If we caution them to handle it with care, generally that should be good enough. But whichever clients want to go with a sleeve, it is available from the manufacturer. The second thing we always talk about is the material compatibility. Some sort of fear psychosis usually we come across. By putting UVGI, the electrical cables will melt, the filter material will melt, etc., etc. That is not true. Okay, we have a lot of information, which 1 or 2 slides we will also share with you here. Now, inorganic material like metal, glass, they are not affected by UV. Okay, UV will react only with elastomer. You can say organic rubber kind of material. What are they? Could be the door gaskets in AHUs, because to make it airtight, we may use some sealant gasket. It may react depending on what type of organic material it is. Some of the filters, they use some certain binding material. Okay, they may be affected. So that we need to be checking. Usually filters made of woven media, like laid up glass media, example HEPA, they are not affected. Okay, all this information is available. ASHRAE funded 2 research reports, RP 1509 and 1724. These are available on ASHRAE websites also, if someone is interested to go through. So they have studied 50 plus polymeric material, right, where they said UV will react. Now they graded them into 4 categories. Rating A, no effect. B, minor effect, meaning only the color will change. So you can ignore B also. Moderate effect is cracking, slight pitting. So here consider shielding. Rating C. And rating D, severe effect, not recommended. So most of these you will see the material that are used in air handling unit or ducting. Ducting is metal, right? No exposure to any sealant unless duct to duct pieces we are putting a certain rubber material. So once we know what material we are talking about, if we can locate them and refer this chart, we can find out whether it belongs to rating B or rating C or rating D. We have some 1 or 2 examples to share with you. So what this research report says, the drip pan, drain pan. So pan made of LDPE is better than HDPE. If the energy intensity is less than 1000 microwatt intensity, no impact. If it is more than 1000 microwatt, fissure or leak may occur in a HDPE pan after several years. Now, instead of HDPE or LDPE, if our drain pan is metal, which I guess is the case mostly in India, mostly, it is generally made of stainless steel, etc. If it is metal, this doesn't arise at all. Electric cable, more than 11,000 microwatt intensity, If we have 2 mil thick PVC wire, it may short over 8 years. Okay, so these reports give very interesting information. So there is nothing to be afraid of in using UVGI. The material compatibility should not stop us from using UVGI to derive the benefits of enhanced IAQ, improved energy efficiency. Whenever we have some doubt in mind, the simplest thing we can do is simply shield. If there are some cables running, we are not comfortable, just shield it with some GI sheet or SS sheet or whatever, so that UVGI will not penetrate. Last 2-3 slides on maintenance. If at all UVGI is used inside, we have to necessarily put a caution sticker so that people who are entering into the AHU room, they will be aware. The AHU has a UV lamp, so that cautiously they will handle. Whenever there is a dust formation, we are allowed to gently wipe with a cotton cloth wetted in alcohol. You can also follow manufacturer's recommendation. One very key maintenance aspect, we keep hearing some feedback, we went for UVGI, but we have not seen any significant improvement in the pathogen count when we do a lab test. The reason is, as we discussed, mainly it has to do with the energy field. If we have a large coil not fully bathed in UV energy, as we saw in the photographs, there are a lot of low intensity spots, then automatically removing the biofilm will not be possible. One easiest way we can do is, along with the logbook that we maintain for AHO rooms, like last time the filter was cleaned on such a date, motor was lubricated, etc. Also, we should have this kind of a maintenance practice. This Sabdex plate doesn't cost much. Hardly some 100-200 rupees it costs, some 10 or 12 numbers. So hardly per piece it will be 80 rupees or less than that. So once in a while, maybe every few weeks, after you apply UVGI in your AHU or whatever, rooftop unit, package AC, ducted AC, etc., just touch the Sabdex plate, close it, seal it, take a picture after 48 hours and 72 hours and keep a record in your computer. Week 1, it was like this. Week 2, week 3, you will see this load will continue to decrease if the energy intensity is right. And you should go towards this plane surface after few months time. This indicates the energy field you are able to generate inside is good enough. If you are unable to reach here, it only means the number of lamps are inadequate. The energy intensity it is generating is inadequate. So it is very easy to add more lamps and generate more lamps. So this will really help us to attain the design intent. Some of the healthcare application, upper zone irradiation unit. Very recently, one of our technical committee member wrote an article in ISRE last issue journal, which talks very nicely about upper zone irradiation units. It covers a lot of information. So you may have a look at it. Generally, it is mounted above the occupied zone to disinfect lot of spaces. Could be hospitals, colleges, schools, classrooms, etc. Then portable UVGI devices, handheld devices, which can be used for surface disinfection. These portable in-room disinfection units can be wheeled into any operation theater or ICU, etc. when people are not there. Follow the manufacturer guideline. This is a rapid disinfection of the whole room. Wherever the UVGI rays are falling, it will disinfect. This is a very interesting system, very interesting application. Many more applications are possible with UVGI. So if we understand exactly how UVGI works, how to select it correctly, what is the science behind the disinfection, and we apply it along with filtration devices, they really complement each other and help us reach our design intent of making our workplace a lot more safer, healthier, greener and efficient. So all these things we will be able to attain as per our design itself. So I stop here. If there are any questions, maybe 2-3 questions we can take, then we move over to the next presentation from the sponsor.
So, thank you very much for your presentation, and very elaborative, it was and very knowledgeable. One question what I'm looking here, I think that is asking Mr. Khan. Thank you for eloquent decoding UVGI. Can you kindly compare it with ozone and bipolar ionization?
That's a good question. But unfortunately, the bipolar ionization is still being studied. There is no specific document that is readily available. Some of the initial feedback and responses we got, whenever we go for any new device, we want to try new device. Number one, we have to go with some of the certifications which are available from recognized laboratories. We need to take care of safety, that is utmost. So the bipolar and some other technologies, they are of course available in the market, they are being promoted. But from ASHRAE, ISHRAE, CDC, some of these organizations, because all said and done, we can understand the UVGA itself was known for close to 150 years. But now only after the pandemic, we have taken more interest, and we have started discussing about some of the standards, some of the application techniques, whether it is delivering what it is intended or not. Now only we are discussing more in detail. So it all requires time, effort, research funding, etc., and also approvals from these agencies and organizations. UVGA took its own time, maybe 100, 150 years. Hopefully the other technologies should not take so much time. It may be a little faster, but as of now, no such approval or direct comments are available from any of these organizations. So we are also continuously searching for more information, reaching out to more people whom we know through our ISHRAE connects, different agencies. It's going to take its own time to evaluate other technologies. But meanwhile, if at all someone wants to try taking the input of the solution providers, only suggestion is evaluate the lab results, which lab has tested. So please evaluate and safely apply.
Next question is from Nivedita Jadhav ma'am. If the lamp is not replaced in the recommended number of hours, is there a chances that ozone gets generated? And what is the source of leakage that you talked of besides the corners?
So if we don't replace the lamp after 9,000 hours or 12,000 hours, whatever is the life specified by the manufacturer, the intensity reduces, because we discussed looking at the construction of the lamp. The electrodes are coated with a special coating. So they get vaporized over this 9,000 hours or 12,000 hours, right? So once they vaporize, the energy produced drops. Assuming initially it was producing 1000 microwatt intensity, after 1 year it may drop to whatever, 400 microwatt or 200 microwatt, etc. The lamp will continue to glow, but the intensity generated is less. So we won't be able to disinfect the pathogen efficiently. But no ozone will come, because as we discussed, the lamps are made with certain inner surface coating which blocks all the wavelength other than 254 nanometer. So ozone will get produced only if the wavelength drops below 200 into vacuum UV zone, which is not the case. So we need not be worried about ozone generation after 1 year or 2 years. It doesn't happen.
Next question is, if you are using non-metal ducts with PET laminated, what cares is required with UVGI?
Non-metal duct. Okay. Could be the recent clothing duct, and a lot of improvements and innovation are happening in the duct technology also. So if it is non-metal, if you could find out from the manufacturer of what material it is made of, the basic constituent, organic, what kind of organic it is, right? We looked at all that table, A, B, C, D, and all that, correct? So if you can exactly locate where does this fit into this table that we are showing, that is visible on your screen. If you know the exact construction material, you can always look at this table and see what rating category it belongs to. So unless it is C or D, there is no concern. And generally, from my understanding, cloth ducting should be all right. But mounting the UVGA inside cloth ducting will be a big challenge, I think.
Is the UVGI helps to reduce dust allergies related to health issues? If yes, is there any products for home appliances?
Dust allergy. Okay. So whenever we are talking about dust allergy, allergy is always caused, as per my understanding, though I am not a microbiology expert. All the allergy, if at all we are referring to, it is caused by one of the pathogens only. Like even in while traveling in car, we switch on the AC, the sudden throw of air from the AC, it will start, we may sneeze or the nose will twitch, right? Maybe it is because of certain pathogen in the air. So as per my understanding, if at all you are talking about allergy, it will be definitely because of one of the pathogens. So generally UVGA is very effective in disinfecting any kind of pathogen. If it is in the airstream, if it comes to the air handling unit or the fan coil unit or whatever, ducted AC, package AC, it will be fully disinfected, no doubt about it. But if pure dust is coming inside, will UVGI filter the dust from coming inside? No. That has to be taken care by the filters. But if you are talking about allergy, other than the dust, it could be because of some pollen, some spores which are present in the dust stream, right? If that is what we are talking about, if that passes through the UVGA energy field, it will be disinfected.
So thank you very much, sir. I think all the taken question has been taken care. And now it's time to Chandramani Jha sir. I would like to request Mr. Chandramani Jha sir to take the presentation over there. Before that, a few lines I would like to say here for him. Mr. Jha is from Alpha UV, looking after airside UV business for West and North region of India. Mr. Chandramani is a mechanical engineer with around 10 years of experiences in dehumidifications in IQ division of HVAC domain. So yes, we have again a lot of opportunity to learn from him. And now I request to carry forward Mr. Jha from here. So thank you, Mr. Jha, and it's all yours. Over to you. Thank you.
Good evening, everyone. Mr. Tapas, am I audible?
Yes, sir. Fine.
Okay, okay. Yeah, good evening, everyone. So, first of all, I would like to thank ISRE Delhi chapter for giving this platform to present ourselves. Secondly, I would like to thank Raghavan sir for such a nice presentation over the UVGI. So, I would just take through a small presentation over about the alpha UV, what alpha UV does, and what are the product segment of the alpha UV. Just, just a moment. Just a moment. Yeah. So basically, Alpha UV is basically into the UV business. So we are almost 20 years old company into the UVGI. So we do only UVGI. Like you can say disinfection of the air surface or the water through UV. So we are there. We have almost 300 plus employees on pan India basis. We are the basically market leader for ultraviolet sterilizers for water, air, and the surface disinfection. We have done almost 1 lakh plus installation around the world. Majority of them are pharmaceutical, food and beverage industries, and hospitality industries. When talking about the HVAC segment, we have done 10,000 plus successful installation of the UVGI in AHU and as well as the ducts. We are the first India's manufacturer who manufacture US FDA approved ultraviolet sterilizers for pharmaceutical industry. Our facility is ISO certified. So under HVAC segment, we are basically available with the UVGI for AHU, UVGI for ducts, upper air UV system, and the portable UV system for the surface disinfection. So first of all, I would talk about the UVGI for AHU and ducts. When talking about the UVGI for application in AHU and the ducts, the primary component of the UVGI is UV lamp, UV ballast, which we also call as control panel, the reflector, cable harness, and the power supply cable. There are some accessories like mounting, what kind of mounting fixtures you are using, and then there is a monitoring system of the UV system. So I'll just take you through a small introduction of these components. First of all, UV lamps. So we have already understood what the UV lamps are, what are the construction of, how is the construction of the UV lamp. So the UV lamp which we are available with the for HVAC segment are high output 800 milliamps UV lamp. These are the quartz UV lamp, and the sizes of lamps are available starting from 450 mm up to 1600 mm sizes. So based on these are the 5 modules we are standardly available with. By using this configuration of UV lamps, we are able to do the sizing for any given capacity of AHU or the ducts. So the wattage of the UV system varies from 55 up to 160 wattage. Then there is another component called ballast. Ballast is basically nothing but the driver of the UV lamp. So this is basically the heart of the UV system. Our ballast looks like this. As you can see on the screen. So our ballasts are integrated with the reflector assembly. So that enables it to stay cool inside the HU when you mount inside the HU. It also reduces the lamp harness cable length. Because of that lamp harness cable length, there is a chance of increase of impedance, which ultimately have the implication on the performance of the ballast. So the lesser the harness cable length, lesser the impedance is, and better the performance is. So that was about the ballast. Then the third component of the UV system is reflector. So our system are provided with the parabolic shaped reflector that ensures that all the UV intensity that is being emitted by the UV lamp is focused in a forward direction on the surface of cooling coil. So it ensures that all the UV energy are being utilized. This is one of the installation. As you can see, left hand side a UV installation with flat type of reflector, and the right hand side with the parabolic shaped reflector. So on the right hand side, after the UV lamp, you can see the dark zone. So basically we are utilizing all the UV energy to be focused on the cooling coil. So some of the installation picture. This is the UV lamp system that we install when inside the HU. So we have understood understood the UV lamp. We have understood the ballast, the reflector. Then there is a mounting fixture. So we are available with the mounting fixture for any sort of capacity of the HU. This is basically tailor-made product. So based on the given capacity of HU, number of lamps, the mountings required is sized. A typical installation picture photographs. This is a UV installation inside the duct parallel to the airflow. Return air duct side UV installation. Then there is another accessories which we call as monitoring system. So basically, when you are installing the UV system, you need to ensure, you need to monitor the system whether the system is performing up to the desired level of disinfection or it's not. So in order to monitor the performance, we basically provide the as you can see on the screen, there is a UV sensor. We basically provide the NIST traceable UV sensor which are fixed in front of the UV lamp, which basically senses the UV intensity being emitted by the UV lamp. And additionally, there is a monitoring panel which is installed outside the HU, on which you can monitor the performance of your UVGI system. So when you are intending to install the UVGI system in your HU or the duct, pre-installation and the post-installation, these are the critical things, you know. So under pre-installation, sizing and selection comes. Under the post-installation, performance monitoring comes. So I'll take you through the pre and post part. So when I'm talking about the pre part, when I'm talking about the pre part, the sizing of the UV lamp is very critical. Depending upon the given CFM capacity and the coil dimension of the HU or the duct, the UVs, we basically do the CFD simulation in order to arrive on the given number of UV modules required to get the desired level of disinfection. Basically, when we are sizing the UV, we should opt some scientific approach. We should not go with the thumb rule approach, because if we go with the thumb rule approach, there are chances of the under designing or the over designing of the system. In case of under designing, the disinfection will not be achieved up to the required, and in case of over designing, unnecessarily the OPEX and the CAPEX will increase. So this is the CFD simulation tool which we use for sizing the UV system. You can see on the screen, the first table you see is the input parameter. So for any given capacity of HU, we enter the coil width, coil height, then coil blower clearance. That is the space available, a clear space available for the UV mounting, and what is the CFM capacity of HU. Based on that, it does the simulation on the cloud, and it gives us the result that how many number of lamps are required and at what position along the X, Y, and Z direction the number of lamps has to be mounted in order to achieve the given level of maximum average and the minimum intensity. So having used this CFD simulation software, we basically arrive the circumstances of over or the under designing of the UVGI. This tool also gives us the kill rate of given microorganism in a single or the multi passes. So as you can see, for this CFD which I have run, the tuberculosis bacteria, I am getting a single pass kill rate of 96.5. Likewise for Pseudomonas, H1N1 influenza, and the coronavirus. So this is basically I wanted to bring into your notice that we are using the scientific approach for the UVGI sizing. Then performance monitoring, that was about the pre-installation, the sizing part. Then it comes the performance monitoring, which is the post-installation. So after the UV installation has been done, we are available with the real-time UVGI performance monitoring platform. This platform basically consists of a NIST traceable UVGI sensor, which are self-powered and the Bluetooth enabled. Then it has UVGI CFD cloud processing engine. This engine basically integrates the CFD code, which simulate the movement of air and microorganism through the HU duct with the UVGI modeling tool in order to calculate the near real-time kill rate of various organisms. So once this simulation has been done, the monitoring of this kill rate can easily be done on any smart device using our application called Ultra Coil Look. So basically, sitting across anywhere, you can monitor the performance of your system. Additionally, it also sends the notification and the SMS alert in case of any drop in the performance of your UVGI system. So this is basically the heart of our beauty of our product. Product certification and capability. So we are actually, our head office is located in Mumbai, We have the manufacturing facility in Talegaon, which is near to Pune. We have a dedicated manufacturing facility of 40,000 square feet. This facility is fully vertically integrated, complete control over the quality. Some of the software that are used in our organization, like cutting edge tool, we are focused on the R&D that ensures modern product with exceptional performance. Some solutions such as SAP and Salesforce are used in order to make it efficient operation, which benefits the customer both on the sales and service side. Our UVGI product are UL listed under the category of UL 1995 and UL 2043. So it is highly recommended that the UVGI system which you are using should be UL listed. 1995 is the basic requirement. 2043 is highly recommended. We have been awarded with the ACREX Award of Excellence for our UV product, which we install inside the coil, inside the HU we name as Ultra Coil, and another which we install inside the duct is named as Ultra Duct. So we have been awarded with ACREX Award of Excellence under the category of Best Indoor Air Quality Product. We have a dedicated team for HVAC UVGI installation and support. So the company on service office is located in Mumbai, Pune, New Delhi, Hyderabad, Bangalore, Goa, Vizag, Chennai, and Kolkata. Over 40 professional trained UVGI installers are there who have performed 1,000 number of retrofit installation in a challenging circumstances. We are always maintained with the ample stock of critical spares that includes lamps, quads, balas, and the sensors. Some of the valued customers that includes metro and infra project like Metro, Mumbai Metro, Delhi Metro, Lucknow Metro, we have done the installation. Commercial, we have done Capgemini, Boeing, JPMC, as you can see on the screen. Then hospital segments, we have done tremendous installations. Pharmaceutical and processes, we have done a lot. Some of the valued customer for our water purification, UV based water purification site. So you name any pharmaceutical, hotel, food and beverage industry, 90% of them will be our existing clients. So that was all about the introduction of Alpha UV and their product. If you all are having any query, then definitely you can.
Thank you, Chandramani sir, for your nice presentation and information related to the product and services of Alpha UV. We'll wait for 30 seconds for if any question comes, we'll take it.
There is one query for Chandramani, which is on the chat.
Yes, sir. Yes.
Any supplier in Dubai for Alpha UV products, Alpha UVGI products?
Dedicated supplier in Dubai is not available. So we have supplied to Dubai from India only.
Chandramani sir, if you can share your email ID or
yeah,
number in chat box to everybody.
I will.
So it will be comfortable to all of them to communicate after this workshop. One question is again, can I get this meeting recording to? Yes, definitely. We'll try to get you send this link. So we have some approvals, agreement, permission from the speakers and committee as well. Then we will definitely send you the recording of this meeting.
Yeah, I shared my mail ID on the chat section. So if anyone requires, they can note it down.
Yeah, so I request everybody to take the email ID of Chandramani sir for further any communication regarding the product and services or to Alpha UV. You can take down the email ID regarding further more information. So I think we have done all of the question, taken all the questions, and it was quite a nice session. I would say one of the best session in the UVGI, and specialized that is on disinfecting indoor air through UVGI. And on behalf of Delhi chapter of ISRE, I would like to thank Raghavan sir, journalists, and all the audiences present over here. And of course, Alpha UV, we cannot forget that because of them, we are able to conduct this kind of workshop, this topic. They have supported us, and one physical program is also they have supported in this program also. So we are thankful to Alpha UV for supporting Delhi chapter of ISRE for the workshop. And we are thankful to Delhi chapter team also, program team and staff and all the committee members and all the coordinating person. Because of them, we have conducted this workshop here in this Zoom platform. So thank you very much. Thank you everybody for joining us.
Thank you.
Thank you very much.
Thank you very much. Good night.
Good night.